Anytime. Yeah, so we got the goals we tend to again. Talk about impact. Now, one that I do want to bring up today that we haven't really discussed too much, which is how does the force velocity curve influence performance? Now, we did bring this up when we were going through the slides. First and foremost, guys, what is the force velocity curve? What is the force velocity curve? All right, Haley, you've been quiet. You want to take a shot?
What was the question? I was working on a different one.
Okay. How does the force velocity curve influence performance?
Isn't it if you're going faster, you can't produce as much force, but if it's like slower, you can produce more force?
Yeah, and then we hit peak power somewhere in the middle. Now, okay, effectively, what does that mean for sporting performance?
In some sports, you won't produce as much force because you'll be focused on speed. But then in others, it might benefit you to go slower to produce more force.
Now, can you think of any sports where it's better to go slower?
No.
Okay, so effectively, we're always trying to do things as fast as we can. And remember, when we're looking at force times velocity, effectively what we end up with is power. So we're trying to have the highest power output. Now, when we look at that curve and we understand that everyone has their own inherent curve, what was the big take home that we effectively figure out when we're working with our athletes? What do we need to do?
Is it figure out where their peak is?
Well, it's fine for wherever it is, but like anything else, we probably want to change that peak, right?
Yeah.
So what can we do to change that peak? Or to modify the curve? I hit my chair behind me. That was invigorating.
Would it be get them to develop more muscle?
Bingo. So they increase their maximal force output. So now we've stretched the force side of it upwards, so it'll have ramifications of being able to produce a greater amount of force across the velocity continuum. But what can we do to try to potentially increase that maximal velocity?
Does it decrease mass or maximum force output?
It's not so much, it's not we're trying to, it's going to naturally, we're going to decrease that force output as we try to go faster. But what things can we do training an athlete to try to increase just peak speed?
Is it like develop the muscles that they need to go faster?
Well, that's kind of along increasing that strength for overall force production. But I think that's where we probably want to use things like plyometrics or true speed training so we can increase that velocity ability. So if we take somebody that's initially, this was their peak force and this is their peak velocity, increase that peak force, well, they're going to be a little bit stronger throughout that part of the curve, but we haven't increased that peak velocity. We increased the peak velocity, now they're going to be not just, they're going to be more powerful throughout the entire spectrum.
Okay.
Good. Thank you for joining me on that question.
Yeah, no problem.
What questions would you guys like me to go through? Haley, do you have one? Do you want me to work through?
Yeah, I do. Let me get back to it. So I think you already talked about it yesterday, but it's 49, and it's which of the following decreases resistance to motion. And I think you said it was temperature, humidity, and barometric pressure, like with drag.
Bingo, bingo. So we're talking about drag here. And so as effectively temperature or humidity goes up, you have less drag, okay? However, for air pressure, it's when pressure goes down, we have less, we're gonna be able to go faster. Because the idea, like anything else, with higher humidity and with a higher temperature, the molecules are moving faster in the air, so it's easier to kind of slip through. And then at the same time, the humidity almost even like, I don't know, it lowers the viscosity, makes it easier to move through the medium. Now, not water. Obviously, water is a lot more driving force than air. But then, when we look at the air pressure, when we're going through a lower amount of pressure, we can go faster. So, in theory, if you could don a spacesuit and run inside of a vacuum, all of you guys would probably be able to run at over 30 miles an hour because you wouldn't have any wind resistance going against you. Not all of you. Some of you guys pulled that off. Does that answer your question pretty well?
Yeah, that helped. Thank you.
Awesome. What other questions can we go ahead and talk about, guys? Next, we talked through abdominal density, and then also how vitamin D and K are important here, and then calcium is the key, followed by magnesium and maybe strontium, but I'm still reading on that. Because there's a lot to know. All right, so Jessica and Kylie, you guys threw out one that you guys were interested in, and Sydney kicked us off with one. Wow, okay. Cam, any other questions you want me to go ahead and go through?
Nope, I think I'm good.
Awesome. So I did go through manually in Blackboard, and if you haven't taken a quiz or a homework or anything like that, and I plugged in a 0, just so everybody really knows how many points they currently have out of how many points are possible, and everybody's on the same page, because for some reason Blackboard doesn't do that, so I have to go through and manually do that. So if you're hearing me say that now out loud, or you're listening to this later and you're now obviously, hopefully things are making sense. If you missed and there's supposed to be a makeup grade, there's some type of mistake that I've made on my end, always be nice. Just shoot me an email. That's why we want to get this taken care of now, when we're still 2 weeks away from the final, as opposed to time on the final. I've got through, after a lot of time, grading everybody's presentations and your papers, and I want to say that I've been pretty happy. I think a lot of you guys did a great job. Some folks, they didn't really give it a shot with that math, which it reflects in their grade, but a lot of you guys really gave it what for. I mean, yeah, it wasn't perfect, but you know what? You honestly gave it a good effort and were at least thinking it through, and that's what I was really looking for. Some of the major mistakes that a lot of people made, but I tried not to be too brutal, which was we were having individuals, when they're looking at a movement and the muscles being used, so for example, if I'm doing a bicep curl, when I'm lifting the weight up, what muscle am I using to lift the weight up? It should be really easy. You can type it in or say it out loud.
Biceps.
Yeah.
Okay, good. When I'm holding the weight still at the top, what muscle am I using?
Wouldn't it just be the same muscle?
Indeed, it's the biceps brachii. Now, when I'm lowering the weight, what muscle am I using?
Tricep.
I'm still using the bicep.
Oh, okay.
Does that make sense? If I'm controlling the weight at all, or even if I'm just letting gravity take it, it's actually going to be the bicep that's still getting a little bit of an eccentric contraction. And that was
So would the tricep not be activated at all, even though you're doing extension?
not when we're going against gravity, or when we're pulling us down, gravity's doing the work, the bicep is the one resisting that work. Your tricep isn't working. You're gonna get a little bit of antagonist activation, but that just keeps our effectively joints from dislocating. But when it comes to doing an exercise, when you're contracting the muscle, the concentric, so the shortening, it's still on. When isometric, it's still on. But then when we're lowering against a load, that is going to give us an eccentric contraction of that same muscle. And that was a mistake that a number of people made, because they're like, oh, well, now the hamstrings are firing. Like, if the hamstrings are firing in that position, you would shoot yourself into the ground, which is probably not your goal given the athletic endeavors that different groups were doing. And it's an easy mistake to make, which is, once again, whenever we're resisting gravity, so when I lift my arm out, that's my deltoid lifting my arm. When I lower my arm down, that's still my deltoid controlling my arm. Now, if I hold my arm out and just let it fall, my deltoid wasn't actually contracting, but it still had a little bit of eccentric force. Now, if I held my arm out and then I pulled it down with my lat, now I'm actually utilizing that antagonist to the initial. And like I said, I didn't take off like 100, well, it was only a 50-point project, so obviously I didn't take off 100 points. But I didn't take off 20 points because people made those mistakes. But I did point them out and I at least wanted to speak about it so it could be recorded. So when everybody else and yourselves have a chance to look through your grades and then look at your papers, be like, okay, now I know what he means when he's talking about that. And also just for future information for yourselves, when you're trying to think through actions and then what muscles are going to have to deal with which forces. So, hooray. Now, after that, I think that was all of my major notes of things that I really wanted to talk through. So, yeah, guys, it's still just going through the final exam review, making sure that you guys are comfortable with what's going on. Any other general questions, comments, concerns that I have? Remember, velocity is going to be, which number are we looking at there? Let's talk about this.
I meant to put vortex, not velocity. Sorry. It's number 55.
Hey, no worries. Remember, vortex is the swirling force.
Okay.
Yeah, velocity is just effectively the magnitude of the speed that an object is going. So it's just how it moves, but turns out you guys have seen that well before many a times. Okay. Talked about that. So anything else that you guys would like to review or talk about, since obviously we haven't exactly been going for the longest period of time, but we're also not trying to punish ourselves with work. And since it turns out the presentations were all online, you guys didn't have to watch them or otherwise.
I have a question about the grading of the final exam.
Yeah, what's up, Blaine?
So you said that one of the options is to not do it twice if you get the grades you want. So
Yep.
Will you get a grade back instantly, like it's all multiple choice and you'll get a grade back right then, or is
Good
there going to
question,
be
Blaine. It's mostly multiple choice. Obviously, there's going to be a number of essay questions, and obviously there's a number of mathematical questions. So, like anything else, I'm going to try to grade them relatively quickly. And if you feel confident, like I think I'm pretty sure I got an A on that. Like I'll grade yours early, so you can see your grade, but you won't be able to see everything you got right and everything you got wrong. For if you then take the group exam. Now, obviously, if you look at that and you're like, well, if I just double that over, I've got the grade I want in the class. Like, have a good one. Like, don't punish yourself with work. You guys focus on, finishing up the rest of your classes and getting good grades in that. Good question, Blaine. And actually, while we're talking, pull up Blackboard and take a look at one little thing. Go figure, I'm going to pull it up on the other screen because you guys don't need to know how other people are doing. And boy, howdy, I am really comfortable with being done with this, effectively being a professional grader. And I thoroughly enjoy these, albeit brief, but occasional times that we can get together via Zoom. And I really appreciate it when you guys obviously ask questions and unmute yourself, because otherwise, effectively the only person I talk to is Norbert. And when I talk to Norbert, I'm typically just telling him to quit barking at things that don't matter. He's been really barky recently. And by really barky, I think it's just because I'm stuck at home and I'm noticing it, because normally I'm not home that much. So, oh, an easy one that people are going to mess up is, everybody, at what age do you quit adding to your bone mineral density?
Never.
Exactly. You only stop adding to it whenever you're no longer doing enough stimulus to increase that bone mineral density. Now, at some point, there is going to be effectively a limit to how dense your bones can become. But like anything else, it's going to be pretty darn far for most people. Okay. Good. Now, another question is, how are fast twitch muscle fibers different than slow twitch fibers?
Their oxygen use, like their oxygen metabolism.
Yeah, type 1 are going to be far more aerobic than type 2. What else?
Their speed of contraction.
Yes, the velocity is going to be higher and the power output is going to be higher in our type 2 fibers. Good, what else?
Fatigability.
Yes, turns out you're going to be fatiguing out our fast twitch fibers far faster than our slow twitch fibers. Our fast twitch fibers are also going to prefer to use carbohydrates as a fuel. Our slow twitch will be much better at using fats as a fuel, and obviously doing so aerobically. But think about how many actual individual motor or muscle fibers get recruited by each individual motor unit. So how's it different with the motor units? All right, so we have is referred to as Henneman's size principle. So you guys can see over here where our type 1 fibers, our actual alpha motor neurons that go to them, recruit a much smaller number of individual fibers. Now, as we start to try to increase the amount of force we're producing, we're then going to start recruiting our type 2 muscle fibers. Our type 2 muscle fibers are really going to be kicking in once we're getting up to much higher loads, and they also recruit a much greater number of individual fibers. So we're going to be recruiting more fibers per motor unit with our fast twitch as opposed to our slow twitch. And like anything else, that means in turn, we have to produce enough force to tap into them. But then at the same time, obviously those are going to be our most powerful, strongest fibers that are going to really help us get work done. Does that make sense to you guys? Let's drop that in there because it's fun. Oh. But seriously, guys, does that make sense? If you don't mind saying something, so I feel like I'm not talking to myself.
Yeah.
Thank you, Blaine. Well, guys, if that's all the questions that you guys are coming with today, that's obviously more than fine. Make sure that you guys are going through and that you've got everything done and ready. Obviously, if you're worried about your grades, we have all of those different extra credit opportunities, so you can go ahead and work on those and get that stuff in. I obviously know some of you guys don't have as much free time as others, so like anything else, try to stay on top of it. Can you guys read the picture I've got up right now? So I don't know how you guys are doing with your end of the semester bingo, but I haven't gotten any of these yet. I'm thankful that I haven't had any of this yet, but I definitely have thankfully had a number of these. And I've had two people that whenever they submitted their papers, it wouldn't even open on Blackboard. So we've already had that fixed, and I'm just waiting for whenever this happens. Oh yeah, and this always happens. That's a given. So does that. And definitely that. But hope you guys are doing okay. Make sure you guys are keeping that head above water. If you guys are having any other questions, concerns, feel free to contact me. If you guys want to do just a quick little, Zoom and talk about any of the things in the class, just let me know. But otherwise, if you guys don't have any other questions of things you guys want to go ahead and review, and this one we're getting really close to, but that's me, obviously not you. And remember, gentlemen, like true toxic masculinity, we don't cry, our eyes just sweat on occasion. But nothing else? Everybody's pretty good? All right, well, 1 second before we go ahead and close out. Yeah.